just because you can jump off a skyscraper doesn't mean you probably should. And even when your code seems to run just fine when it looks like it survived hitting the ground after jumping off a skyscraper, or at least kind of sort of survived, doesn't mean you should necessarily be writing your code that way. Well-formed code is easier to debug, it's much more efficient when you're working as a team, and if you are looking at your code later on, or someone else needs to be brought into the team, if they're working with well-formed code, it's a lot more efficient. So let's talk about what you can do better in coding. And maybe you're doing all these, but I'll go over about 5 points that are big helpers in this area. One of the big ones is write some manuals, write some documentation, whether that be a text file or whether that be written down on paper. I always like it in a digital format, that way I can keep it right there with the program. These manuals should cover things like any of your external dependencies, any of your system requirements, any other programs that they depend on, environmental dependencies, and a brief overview about what each of your code items are. This should be your programmer's reference guide. This isn't necessarily a user's guide. This is more, when you go to look at this up, you should list every type of file that you're adding as a part of your program, if it's a multi-file program. And what are these? What is your main entry point? Do you have an install file? And where are these other items intended to be included and included from? Probably map out those dependencies within your program as well as outside your program. Another thing to do too is within your code files, adding some comments. You know, I can tell you from personal experience, I've had programs that are more than 20 years old, and they used to be a big thing that I would use all the time. I used them for all kinds of different things. And now, I mean, I've looked at them, 20 years later on, and I can't figure out what the item was meant to do. It's just so, because I didn't comment it, I didn't write the manuals, and so it became a thing where I just didn't even bother to reuse the old code. I looked at it and it's like, what, this is going to take me days to interpret this, because it was huge files, sometimes hundreds of lines long. I knew it was an important program, but I went ahead and rewrote the whole thing. Took the time to rewrite it because I figured it would be a lot to try and interpret that whole thing. Comments can be added within your different functions and within your any type of significant block of code. You want to comment that. You want to talk about anything that you think you might want to know later on, or someone else might want to know later on. What is this class for? If you're writing in a class or an object, what is this function for? What's it supposed to do? What are the things that you should be watching for as far as the things that, variables it's supposed to take, and what returns it's supposed to give? What special things does it do? What special conditions are you looking for? Those types of things should be in your comments, so that way you can just briefly look that over. You might be just fine looking at the source code and interpreting that, but someone else, a lot of other people, if you're adding someone else to the team or if you're looking at it later on, those comments could be a real lifesaver, especially knowing like what it's supposed to call. That could be another spot where you write down dependencies and stuff like that. References to other files. This deals more with whenever you're dealing with a lot of different files in your program. Maybe it's a you've got, let's say it's a Java application here, and every class is in its own file. That's a very common thing to do with Java, or with C is also like that. A lot of objects are just put in their own individual files. Having the references which they have to other files, to other classes, to other objects up there at the top. Some languages like PHP and Python, they don't really require, there's a number of them that don't really require those references to be up there at the top. But I'd still put them up there if you can. If you're referencing a library, put it up there at the top. That way you know that this is going, if you're looking at debugging or you're looking at the future of it, you know more about what the other things are that are going to be messing with it are. You know, when you create a class, it's like, where's this from? Oh, it's from a library. You know, okay, I can see that. I've got a library imported. I can look up there at the top. It's an easy to find spot. Now, there are some cases where you're going to require a library or import a library where you won't easily get you won't be able to just put it up there at the top. Maybe you are first analyzing some stuff and then figuring out which libraries you need. If you are doing that, I would definitely put a comment up there with all your other imports or includes or requires to make sure that you are aware of the possible inclusion of these other items as well. I would make notes of that. So keep my references up there at the top. That way it's easy for me to tell everything else that's affecting my files as well. And keeping a pattern in your declarations. You know, if there's certain spots where you're going to declare a variable or declare a class, you know, like say if you're building classes and maybe you want to put all your variables up at the very top section of your class, you don't want to break that pattern and later on create a variable declaration that's down towards the bottom. You want to have them all up to where you can easily see so that we can kind of get a picture of what this class is, and you don't have stuff that just comes out of nowhere on you. So having a procedure which you build your classes, you build your functions, and following that procedure. Don't break from that procedure. Keep your patterns. Create patterns, keep your patterns as much as you can. And the last one here is actually pretty important too. And using encapsulation. This means every function that you write. Most languages allow your functions to be pretty well encapsulated, but you want to make sure that as much of that as possible is inside of that function. You're not trying to depend on a bunch of environmentals. There may be some exceptions, and then you want to document those exceptions, where maybe the function is meant to set up an environment, and therefore it needs to manipulate the entire environment. But most of the time, your functions will be something where you're, you know, processing some other type of information and turning it into another type of information, or you know, checking for something and returning a value, or whatever it be. And you want to make sure that all of what you need for that function to work is sent to that function, and it doesn't require a bunch of a bunch of items that are not being added to it through the variable arguments. And it doesn't do a lot of manipulation to the environment around it either. You don't want to have the whole environment of everything else change because you ran a function. You want it to be encapsulated so that way you can test that function and make sure that it's doing exactly what you expect it to do. And it makes debugging a lot easier at that point. It makes modifying your program easier. If you decide you want to extend that program and do more, you know what that function is, you know what it does, and you don't have to sit down and retest your entire program because you made one little thing. That you can wait till you're ready for the final production testing and then go ahead and test everything. But just to make minor modifications, you don't have to do nearly as much testing. You modify that one function, make sure that function's working correctly, and then everything else just calls that function correctly. And same thing with classes as well. Classes should be their own little programs with comments up there at the top, comments up there at the top of the functions and of the classes or other objects that you'd be creating. Sometimes, like Python is just terrible for that. JavaScript is just terrible for any type of encapsulation. But some of the other languages like PHP and C++, they'll give you very good encapsulation. You can create private variables that are contained in there. They can't be accessed outside of that object, and you want to make sure that everything that's coming in to change that calls a function or calls a property, calls whatever it is that you can use to check that and make sure it's valid, make sure it's something that would be expected to be there. So that way you have kind of that class is like a program. You know, if that class is supposed to be an IP address, it's going to be what you expect it to be. It's going to work as an IP address. It's going to work as a box dimensions. Maybe you're adding a 3-box dimension, and then any changes that they can notify as they need to. Maybe there's events that you want to throw out there if you're keeping track of these values. But that encapsulation, making sure that you're not accessing variables directly that should be private. So those are things that are good to get in the habit of if you really want to get well-formed code that is easy to collaborate with, look back in time, pull out your old programs, extend them. Yeah. Thank you for watching.